So what about this one? So what is the answer? Can you be a little faster today? All are? It's reflexive, symmetric, and transitive. Is it so? So x comma y, x and y work at the same place. So x comma x is possible, y comma y is possible. Yes, it is reflexive. Correct. So is there, everybody knows the answer for this? There is someone who doesn't know, please let me know and explain. We join together. So, but you know what a reflexive transitive is? You didn't go through? Okay. Okay. Now it will be slightly tough. But I have to go in depth. Okay. As of now, you work on it. I help you. So, what about D? X and Y live in the same locality. Same. What about X and X is exactly 7 centimeters taller than Y. So it's not reflexive because of what reason? Sorry? So one person cannot be taller than himself. So in this, X comma X does not belong to R. Why? Obviously, one cannot be taller than. So next is, what about X comma Y? If at all I assume X comma Y belongs to R, what am I trying to tell you? No, X comma Y belongs to R. What is the meaning of this statement? X is exactly 7 centimeters taller than Y. So if I write Y comma X belongs to R, what am I trying to tell you? Shorter. So it will change, right? So it's a relative perspective. So when X is taller than Y, Y cannot be taller than X. So it does not belong to R, hence it is not transitive. Sorry, not symmetric. Symmetric. What about transitive? Cannot be 14 centimeter tall. So just to give you an explanation, observe X comma Y. I hope everybody got the logic of it. X is 7 centimeter taller than Y, right? So if I write X comma Y belongs to R, then what is the meaning of this? X is 7 centimeter taller than Y. If I write Y comma Z belongs to R, very simple. All you need, see, one hint I tell you all for the benefit of only thing you need to concentrate.
Y is taller than X.
So first element, Y is the second element. Concentrate on it. Okay. Now can you try to tell me what is the meaning of it? I'll be happy if you tell me correctly. Y is exactly that's it. So here X is greater than Y by 7 centimeter. Here Y is greater than Z by 7 centimeter. If at all I write X comma Z, what is the meaning of this? So X will be, so I need to say that X is greater than Z by 7 centimeter, but it is not possible. Why? Because if you add these two inequalities, just to solve, you know how to deal with linear inequalities. No? When you add them, X plus Y will be greater than Y plus Z plus 14. So if I take the Y to the other side, Y and Y will get cancelled. So X will be greater than Z by 14 centimeter. Hence, this does not belong to it. Hence, it is not transitive. Make sense? So I'm assuming everybody has already tried it. The next one, something to do with gender. Not possible. X comma X is not possible. If you write X comma X, what are you trying to say? The first element is a wife of. Okay. You know the answer. Obviously, it's not. Similarly, X comma Y, what is the meaning of it? X is the wife of Y. If I write Y comma X, what is it? Y cannot be the wife of X because the gender changes. Right. What about transitive? Grandmother. Which one? X comma Y belongs to R. When you want me to write that fourth case? Grandmother, concluded. So X comma Z obviously does not belong to. Right. Not thinking about it. The next case, grandfather. Okay. So X is the father of Y. So X comma X is not possible because for obvious reasons. X comma Y, X is the father of Y, obviously the reverse is not possible. Similarly, transitive, X comma Y, X is the father of Y. If you write Y comma Z, Y is the father of Z, then X and Z will be, one will be the grandfather of other. Correct? We are in the English section. Okay. So here you have the solutions. So we go to the second. We think from here we have the generic values. Show that the relation R in the set R. What is this R? So the one which is in bold is the real number system. So what is the other way to write a real number? How will you write it? Write it as minus infinity plus infinity. Both mean the same, right? We use it in functions often, so please be careful about it. Show that the relation R in set R of real numbers defined as this R is equal to A comma B. We have the collection of the ordered pairs in such a way. What is the relation between them? A is less than or equal to B square. A is neither reflexive nor symmetric nor transitive. So how to do this? So for reflexive, what am I supposed to do? So if does A comma A belong to R? If I take the element A comma A, what condition is it supposed to satisfy? A should be less than or equal to A square. Obviously not possible. It cannot be equal also. It is only possible for one. It is only possible for 1 or 0. Otherwise, 1, 0, minus 1, it will not work. Yeah. But for reflexive, what is the condition? I told you, every element that is present in the input set that is given should get satisfied. So what about symmetric? If I say A comma B belongs to R, then what is the meaning? A is less than or equal to B square. If I say, is B comma A possible? Does this belong to R? Why? But here it is square. Now, how did you conclude this relation? It's a generic variable that I took, right? It's a general variable. I took A and B. It's better you put a number and see. So take a number and see. Suppose I take 1 comma. Shall I take 2? So 1 comma 2, does this belong to R? Yes. So 1 is obviously less than 4. Not necessary that both should get satisfied. 1 is less than 4. But if I take 2 comma 1, what will happen? What is the state? 2 is less than 1 square, which is not possible. So since we are saying that this is existing, since this is not existing, this is not a symmetric. Yep. So what about transitive? It will be symmetric, but here I'm able to prove that there is a pair existing for which you don't have a counterpart. But so when you write the ordered pair, this is where I know where you're coming from. Understood. When you write the relation, so first I told you always start from where? A cross A. So A cross A, how many elements will be there? Real number minus infinity to infinity, minus infinity to infinity, you will have infinite set of such ordered pairs. Out of which, what are the only ordered pairs that you are allowed to choose? You choose only those ordered pairs which satisfy this condition. Among which, can I say 1 comma 2 is one such ordered pair which is a part of this relation. Is this 1 comma 2 satisfying? 1 comma 2 satisfying, but is 2 comma 1 satisfying? So for every such ordered pair which is satisfying the first condition, you should have a counterpart which is satisfying the second condition. It is not like one is satisfying, you cannot conclude it as symmetric. I have something, but I don't have a counterpart. What is the counterpart of it? You should have a 2 comma, which I don't have. Right? What about this thing? You can take another example, like 1 comma 2. Then some numbers, whatever numbers. 2 comma 3. What about 1 comma 3? Not possible. See, 1 is less than 4. Here, what is happening? 4 is less than 9, but it is satisfying. So, what does it tell you? When you're considering the example, You have considered the wrong example. 2, 3. So maybe tell me another number which you can take. Because they have told it is not transitive. So what is it you guys do? Told you solved it. No? What is it you people do? I want to check your notes and tell me. Let's solve it. What did you do? Real number, okay, you can take it. You took 2, minus 2. Okay. Okay. So you are saying 2 is less than 4. Okay. Still you are getting it. No? 2, 9 were there. What did you? What are the numbers you? How did you prove that it is not transitive? But they are saying it is not transitive. Means we need to break our heads to find out those numbers. It's not transitive. So think and tell me. Think of such numbers which will make it fail to be a transitive. This one. You can take the 0 also. No, minus 1 is right. Did you understand? So when you think only of positive numbers, it will not work. You need to think of a negative number because the advantage is right hand side is a perfect square. So when you keep putting positive numbers, it will keep satisfying. Only when you need to make this a bigger number, make this a negative number. So that is why, what is the example you can consider? 2, minus 2 belongs to R. Does it satisfy? 2, minus 2. 2 is A. Less than or equal to minus 2 the whole square is 4. Satisfied? So yes, this belongs to R. Yes, this belongs to R. What about minus 2, minus 1? Minus 2 is A. Less than or equal to 1. Correct? Minus 2 is it less than 1? Number line. 0. 1 is here. Minus 2 is here. Minus 2 is less than 1. Is it satisfied? Yes, it is satisfied. But just because these two are satisfied, is it directing us to the fact that minus 2, minus 2, minus 1 belongs to R? Correct. 2, minus 1. A is 2. So 2 is less than or equal to, according to this one, what are you getting? 2 is less than or equal to minus 1 the whole square. Is it right? So hence it is not transitive. So whenever you have these kind of problems, the first hint is, since the right hand side is a perfect square, it will be a positive number. So think of taking the negative numbers because the left hand side is a non-square value. That is a hint. Okay, so this is where we miss. I hope you are clear now that these two are existing, but you can take one pair and tell me that it is transitive circle. But I am able to prove that there is a pair which is not leading us to transitive object. This is more important, right? Am I clear with this? How did you solve this? How did you solve? This one is the one you had. Okay, okay. Shall I proceed? Correct. What examples they have taken? See, they have taken some 3, 2, 2, 1.5. So for this problem, it is all, I told you, no, it is not necessary. You always need to go with general values. If you get stuck, take numbers. Okay. What about this one? check whether the relation R defined by the set 1, 2, 3, 4, 5, 6 as R is equal to A comma B such that B is equal to A plus 1 is reflexive, symmetric or transitive. They are asking us to check. So it is our responsibility. Obviously, one thing I'm able to see, it's not reflexive for sure. So if I take the element A comma A, what should it satisfy? B1 A. So A should be equal to A plus 1. 1 is equal to 0, which is wrong. So this does not belong to R. What about symmetric? Not a. So obviously, right? B is a smaller number. Sorry, B is a bigger number. So A comma B, if I assume it belongs to R, right? B comma A does not belong. So if at all you are not able to understand with this, you can take the numbers. So shall we take 1 comma 2 belongs to R. Does it satisfy? 1 comma 2 satisfies. So 2 comma 1. So if I put 1 here, this is 2 plus 1, you will get 1 is equal to 3. That's not satisfy. So what about transitive? Not a. How did you do? Exam numbers or you took it like this itself? Okay. A comma B belongs to R. So what I do is I'll parallelly keep writing the mathematical operation. So what is the meaning of this? B is equal to A plus 1. If I assume B comma C belongs to R, which implies C is equal to B plus 1. What about A comma C? I'll write it like this. But let me add and see. B plus C is equal to A plus B plus 2. I added both. So B and B are gone. C will be equal to A plus 2. What should be the value here? It should have actually been 1 according to this. So this does not belong to it. Hence, it is not transitive. So it is not satisfying either of the conditions. Am I right? See, if at all you have done with numbers, you are right. It won't be under the curve. I just did it only for general understanding. Even numbers which one. But you can still make a note of this. It is reflexive and transitive. Okay. So they have asked us to prove them. Okay. Show that it is reflexive and transitive. So how you prove? For reflexive, obvious reasons. Because of the equality, right? A comma A belongs to R because A is equal to A. What about symmetry? Not possible, right? So A comma B belongs to R, which implies if I take them to be different numbers, A is less than B. I'll remove the equality symbol. So B comma A, what should it imply? It is B is greater than A. It is contradicting itself. Oh, sorry. B is lesser than it. It's contradicting itself, right? So this does not belong to. Right? What about transitive? Is it possible? So B belongs to R. What does it imply? A is less than B. B comma C belongs to R implies B is less than C. A comma C belongs to R should imply what? Add them. When you add them, A plus B is less than B plus C. B and B will get cancelled. A is less than. Yeah, what is the answer for this? A is less than B. Check. Reflexive. A comma A. Had it belong to R, then what should it imply? A should be equal to A cube, which is not possible. Right? So it does not belong to R. What about symmetric? So you can take a number in this case. What are the numbers you want to take? So 1 is less than 8. If I take 2 comma 1, what does it imply? 2 is less than 1. Right? Which is not possible. What about transfer? Not a. So what are the numbers you have taken? What are the numbers you have taken? Yes, okay. What are the numbers you want to take? 1 comma 1 comma half. But 1 comma half doesn't satisfy. When a 1 is less than 1 by 4, which is not possible. Maybe half comma 1 we can write. Okay. So half comma 1 belongs to R. So what does it imply? 1 by 4 is less than 1. Okay. Equal to it. Okay. So I do only equal to condition. 4 now. So A comma A belongs to R. Yeah, we can say that correct. Decimals, what is the it's real number, no? It's real number. If you take half, for instance, not have half is not less than 1 by 8. It's less than, but here the condition says less than. See, for example, I take 1 by 2 comma 1 by 2. Okay, does this belong to the relation? No, then it's gone. So 1 by 2 is less than 1 by 8. Wrong, that's 0.5 and this is 0.125, right? So it's not possible. So every number in the domain set should satisfy. It is not possible. So here what did we take? 1 by 2 comma 1. No? 1 by 2 is obviously less than 1 accepted. Okay, what is the other number you want to take? 1 comma 1 comma. You guys tell me. One comma 1 by 4. No, if I take 1 comma 1 by 4, I'm trying to say 1 is less than 1 by 64. What should I take? Think in terms of negative. I told you. Whenever you have these kind of cubes, think in terms of negative numbers, you'll understand. Guys, did you solve this or not? We could see solutions. Okay, for whole number, you got it as last. Then take a fraction. Think of it. Who are supposed to solve it in the exam? It's better to break your head now than in the exam hall. Think. Fraction or decimal, whatever. Fraction. Anything satisfies, sir. Is it working? So the numbers minus 1 comma. You want to take 1 comma minus 1. So 1 comma minus 1 belongs to R. But check no. How is 1 less than minus 1 the whole cube? Cube will have a minus. So you can take minus 1 comma 1. Are you able to think? Think of fractions. Think of fractions. Think of fractions. 3 by 2. And what numbers? You want to take 1 comma 3 by 2. 1 comma 3 by 2 belongs to our correct. See, when you put 1 here, 1 is less than 3 cube is 27, 2 cube is 8. 27 by 8 is definitely greater than 1. Okay, then what will be the other number? The other number says it should start with 3 by 2. Then you need to choose which number here so that this number and this number put together will make you fail that it will not be transferred. It should, you should prove somehow it is straight. We need to choose that kind of a number. 0.5 comma 1. It should be 1. 0.005 is 1 by 0.005 5 by 100, 1 by 20, right? 1 by 20. Okay. Does this belong to our? Belong to our apartment. When you put 1 here, 1 is not less than 1 by this. They need to check those numbers. Are you able to understand what I'm trying to say? Okay. I want somebody to come up with that number. First set, first order. 1 comma. We'll take 1 comma 3 by 2. Does this belong to our? Yes. Because 1 is less than 27 by 8. Okay. Next, what is the number? So the next order pair should be 3 by 2 comma. We'll take 4 by 3. Okay. Then what is happening here? Is it satisfying? So 27 by 8, and here you are getting 64 by 9. So this is how much? 27 by 8 is 3 point something. 64 by 9 is. But still, what will happen? 1 comma 4 by 3 also belongs to our. When I the 7 point something should 1 is less than 7 points. That should not. Got it? Not reflexive. This belongs to our one. Does not belong to our Varavekina. That is what I'm saying. Oh, okay. So it is transferable. I didn't see. I thought what we should do that it is not. I don't know what is the answer. But answer says it is not. 2 by 3? 3 by 4? Working? 4 by 5? Working? Nothing. See, what you don't need to do is increase the denominator. Keep increasing the denominator. Correct. From here, I'm telling you the logic. So, is this working? It's working. So, 2 by 3 is less than cube. Cube. Wait. Working. 27 by 64. 2 by 3 is 0.6. Less than 27 by 64. Big number, no? Which one? Not working. So none of you could crack it. Got it? Got it? Minus. Okay. Working. So you put the negative numbers, no? So minus half is less than 1. 1 is less than. How is positive number less than a negative number? Okay. See, but definitely you need to get a fraction. So 3 comma 3 by 2 is one such number. Okay. 3 by 2 comma 6 by 5 is another such ordered term. Okay. So when you need to think about that, that's what I was trying to track. See, when you need to think about this, right, you need to concentrate only on the first and the extreme number, because what does the transitive speak about? Because transitive connects the first number and the last number, right? So here, what the logic they have used is they check 3 comma something, and here a number 6 by 5 is taken. Okay, so that this 3 and 6 by 5, how is it working? See, 3 is less than, what is 6 by 5? The whole cube. 216 divided by 125. It is less than 2. Because 125 2 is 250. It's less than 2. So intermediate, they have filled a number which satisfies, which is 3 by 2 and 3 by 2. So they made it fail here. So the testing was done by taking these numbers first and then putting the number in between. So whenever you have something like this, whenever you have these cube values, right, take the extreme values and then solve. This one. Yeah. So maybe we need to do the negative testing. You first make it fail and see if at all you fill the intermediate numbers which are working. See, that's what they have done. What is done is you take 3 here. I told you, no, take 6 by 5. Now you got the logic, right, of what they did. Now try with another number, you yourself try and see you get the idea. Okay. So this one, okay. You need to check the extreme cases of the solution. See, for example, A is less than B cube further. You're saying A comma B belongs to R. Right? So when A is less than B cube, this is what you're getting. You say B comma C also belongs to R. Then what will happen? B will be less than C cube. Right? Then if I take A comma C, what should happen? If I take A comma C, what should happen? Then A should be less than C cube. Right? So if at all I take the extreme condition and see. If at all I take the extreme condition and see, extreme is equal to. right? I'm just doing a testing, okay? B is equal to C cube, then A is equal to C cube is what I'm getting. In the place of A, what can I substitute? Here, what will you get? C cube at the B put. So this is giving you a hint that it cannot be transmitted. I'm just giving you the thought process. So this is making you think that it is not transmitted. So you need to prove that it is not transmitted. So first itself, by looking at the question, you will understand it is not transmitted. That is why in that square problem also the same issue occurred. That is why I told you take the fractions into consideration. Are you able to understand? So take the extreme values and then check. So what you can do is, for you to get a better understanding, you can find other such pair. But what will be the logic you use to find the other such pair? Fix the first number and fix the last number and make it fail. So intermediate, you make it success. I explain what I use. But when fractions come, you know. If I take equal to, then I am trying to ignore the inequality. Had it been an equal to thing, we would have solved it long back. So when I took the equal to condition and then solved it, I am getting this kind of a thing. So it is telling me that there is a possibility that it will fail to be a transfer. Okay, I'm saying that is only giving you a hint.